In this video, we're going to learn about the unit circle and, more importantly, how to use it. So the unit circle is a circle whose radius is 1. Think of the root of the word unit, and you'll see that it means 1. First thing we're going to think about is what our cosine value of theta is going to be in our unit circle. So thinking back to SOHCAHTOA, cosine is going to be adjacent over the hypotenuse. So here, the adjacent side in the reference to the angle is x, and we'll put it over the hypotenuse, which is the radius here, which is 1. So really, we end up with x equaling cosine of theta. Let's now think about sine of theta. So, SOHCAHTOA, sine is going to be the opposite over the hypotenuse. So here, it's going to be y over 1, which is just y. So really, y is sine of theta. Next one we're going to think about is tangent of theta. To help us figure out that is, let's divide sine of theta by cosine of theta. Well, sine of theta is the opposite over hypotenuse, and cosine is the adjacent over hypotenuse. If I were to then multiply this by the hypotenuse over the hypotenuse, multiplying by h is going to undo dividing by h. So what's going to happen is I'm going to just end up with the opposite side over the adjacent side. Well, what's opposite over adjacent? That's tangent from TOA. So we just figured out that tangent of theta is the same thing as sine theta over cosine of theta. And then we have these other two definitions, which are going to be really important when we figure out the unit circle. So next we're going to talk about are reference angles. So reference angles are the angles above or below the x-axis. That's how we measure them. So not off the y-axis, off the x-axis. If you look at this picture here, this picture is showing congruent triangles in all 4 quadrants. So when we measure an angle going around a circle, we always begin on the x-axis and we move counterclockwise, so in this direction. So if you look here, this reference angle really is itself. So in quadrant 1, that's where we think about the reference angle being. It's always an angle between 0 and 90 degrees. If we have an angle that goes into quadrant 2, its reference angle is how far above it is from the x-axis. And you can see that these two angles are the same. An angle in quadrant 3 is going to have its reference angle being how far past the x-axis it is. And an angle that goes all the way into quadrant 4, its reference angle is going to be how far below the x-axis it is. So here, these are the reference angles in each quadrant, and they're all the same because these triangles are congruent. So when we talk about the unit circle, we're not going to try to memorize all the trig values in all 4 quadrants. We're going to use reference angles to help us out. So let's recall from what we just did that y is sine of theta in the unit circle, x is going to be cosine of theta, and tangent of theta is going to be our sine theta value divided by our cosine theta value. So let's just take a minute to think about what the sign of these different trig values are going to be in each of the quadrants. Okay, so since x is our cosine theta value, cosine of theta is going to be positive wherever x is positive. So here we have that x, which is cosine of theta, is positive in quadrant 1. If you look at this point, we still have a positive x value here. So again, in quadrant 4, x is going to be positive, so cosine theta is positive. If we go to quadrant 2, so talking about the point up here, Here, our x value is negative. So actually, one way to think about this is if n is positive, n being our x value, we're really working with a negative n in this picture. And same thing here. Okay, so in quadrant 2, x, which is cosine of theta, is going to be negative. This point also has a negative x value. So I'll again write that x equals cosine of theta, which is negative. Let's now look at our sine theta values. So sine of theta is y. In quadrant 1, m, the m value or y coordinate is positive. So I'll say y, which equals sine of theta, is positive. In quadrant 2, I still have a positive y value. So again, y, which equals sine theta, is positive in quadrant 2. In quadrant 3, if I think about this m values being positive, here m is going to be negative because I'm going down. So here I'll say that y, which equals sine of theta, is negative. And in quadrant 4, I again have a negative y coordinate. So y, which equals sine of theta, is again negative. Last thing we're going to think about is what our tangent values will be. So since tangent is sine of theta over cosine of theta, if I were to divide sine theta by cosine theta in quadrant 1, I'm dividing a positive number by a positive number. So I'm going to get that tangent of theta is positive in quadrant 1. In quadrant 2, I'm dividing sine by cosine again. Here I have a positive over a negative, which is going to be a negative value. So in quadrant 2, tangent of theta is negative. In quadrant 3, I'm dividing a negative value by a negative, which is going to be positive. So in quadrant 3, tangent of theta is positive. In quadrant 4, I have, again, sine over cosine. I have a negative over a positive, which is going to be negative. So in quadrant 4, tangent is negative. This gives us a little mnemonic saying, which is all students take calculus. That might not be true, but many students do take calculus. So the first letter in each word helps us remember ASTC. So just how we talked about how angles, we start it right here and we go counterclockwise. Imagine following that along. If we first go through quadrant 1, that gives us the A, all. That stands for the fact that all trig functions are positive in quadrant 1. Go to quadrant 2, and the S tells us that the only one that's positive is sine. So moving counterclockwise, all students take calculus. That tells us which trig function is positive. All in quadrant 1, just sine in quadrant 2, just tangent in quadrant 3, and just cosine in quadrant 4.